Now, take out the word problems and go to and go to number 9. So go to number 9 of these word problems. We're only going to do 2 today, so we're just going to make it quick. All right. So we're just going to do 9 and 10 today. All right. Now, one of the sheets that I had to grab besides the salmon colored one was this sheet that says grass strategy. It has 4 of these little tables on it, front and back. All right. This is a good way to break down word problems to figure out how you attack it. All right. Now, I don't expect you to fill these out in entirety, but this should be what goes through your mind as you work out word problems. So, what it stands for is, so whenever you work a word problem of any kind, you want to think of grass. So G stands for given. So that's any information that you're given in the question that you think is important. All right. R is for required. So in other words, what are you required to solve? Or what is the question? What's the required question? What do you need at the end goal? A is for analysis. So this is when you're thinking, okay, how do I attack this? Do I make a table? Do I use a formula? Do I kind of guess and check? The first S stands for solve, and that's where you actually put your plan to motion and solve it. And then S is for statement. So, in other words, you're basically just stating your answer. All right. So that's what this means. So I don't expect you to do this on every question, but this should be what's going through your head if you come across a word problem that you just don't know where to tackle it. All right. This is where you can kind of start to think about it this way. So we're going to kind of use this as we're going through these word problems. So what I want you guys to do is that as we're going through these word problems in each table, just jot stuff down. All right. It doesn't have to be perfect. I just want you guys to just jot stuff down that you think is important. All right. So close the laptops right now. You don't need them. All right. Now, let's look at number 9 first. In total cost in dollars of a membership in a fitness center is given by the function C of M equals 20M plus 40, where M is the number of months a person is a member. In dollars, how much is the cost of a membership for 1 year? All right. So we're just going to go through the whole grass process. So my G stands for given. So someone raise their hand and tell me one piece of information that's given to us that's important. Olivia. Say it again. The function itself. So if I was going to jot this down in grass, I would write the actual function itself. So C of M is equal to 20M plus 40. All right. What's something else that's important? Someone else. Ralph. So M is the number of months a person is a member. That's something else that's important. So you can jot down M is equal to number of months. Is there anything else that you think is important? Just in terms of given information. Anything else? All right. So let's move on to the next part. What is required? So this comes from the question. So what is it asking us to do? What is it asking us to solve for? Someone raise their hand and tell me that. So what is the cost of the membership for what? For 1 year. So they want to know the cost in dollars for the membership for 1 year. All right. So what they want to know is cost for 1 year membership. All right. So now let's figure out a plan of attack. All right. So that's where our analysis comes in. So does someone have an idea of what we need to do? Or what we need to do first? There's a couple of steps to this. What do you think is something that we need to do first? So let's think about it. We're given the function, we're told that M is equal to the number of months per membership. We're trying to find the cost in dollars for 1 year of membership. So first off, do the units match? So in our function, what type of units is being used in our function? So guys, in terms of time, what's the units for the function? Months. Now what did it ask us to find? How much it costs for 1 year? Is a year the same thing as months? No. So what do you think the first thing I gotta do? Convert 1 year to how many months? So 1 year equals 12 months. So we know that 1 year is equal to 12 months. What do you think the second thing I'm going to have to do is? So if this function right here tells me what the cost is after so many months, all right, so what it looks like is that there's a flat rate of 40 and then it's $20 extra a month for the membership. That's what you pay. So what do you think I'm going to do to figure out how much I pay for after 12 months? How do you think I'm going to find it? So guys, if no one answers, I'm going to start pulling. Replace the M with the 12 and evaluate. So plug in 12 for M in our function C of M. All right. So now we're actually going to go for the solving part. So in other words, we have 20 times 12 plus 40. All right. Now, what's 20 times 12? So remember when we were doing basic math skills, there was a zero rule that I taught you. What was it? So remember, basically, if any number in your multiplication ends in a zero, that means your number's going to end in a zero, and then you just multiply whatever's in front of it, whatever's in front of that zero, by the other number. So what's 2 times 12? 24. So we have 240 plus 40. And what's 240 plus 40? 280. So $280 for 1 year membership. And that's exactly what they want. All right. So whenever you go about solving a word problem, this should be what you're thinking to yourself. What can we do to find this? All right. So again, you would have 20 times 12 plus 40. That would be 240 plus 40, which is $280. Any questions on that one? Now, Number 10 was a bit tricky. So for this one, the grass method would very much help with it. All right. So on the next table on your thing, this is where I want you to write down stuff. All right. So I'm going to erase it on my end. But we're going to look at this first. So first, let's just read the problem. So water is being pumped into a 10-foot tall cylindrical tank at a constant rate. The depth of the water is increasing linearly. I can't speak English today, apparently. So at 1:30 p.m., the water depth was 2.4 feet. It is now 4 p.m., and the depth of the water is 3.9 feet. What will the depth in feet of the water be at 5 p.m.? So I'm going to erase what I have here just because I don't have another one of these. But you guys write in your next available thingy. All right. So first things first, let's list any type of information that we think is important that they gave us. So someone who has not talked today, what's one piece of information that you think is important? Riley. In reality, that's actually a piece of information that we don't need. All right, but there's another word next to it that's important. What do you think it is? Constant rate. So that's the part that we want, constant rate. So remember what I said that they put in some fluff? So that part is fluff. You may think that, oh, this is a volume problem. It's not. All right. In the reality, this is not actually very important. But Riley, I'm not saying that you're wrong. It's just a very good example of how you can decipher what you need, what you don't need. All right. So the part that we need from that sense was it's flowing in at a constant rate. So it's coming in at a constant rate, meaning that we have a solid slope somewhere. Someone else tell me another piece of information that we need. Addie. Okay, so it's increasing linearly. Good. So we know that it's going to be some kind of linear function if it's increasing linearly. All right. What's something else that's important? Someone different. So sleepyheads, heads up. Come on. I'm doing this for your benefit. Taylor. Right. So at 1:30, we were at 2.4 feet. So 1:30, we were at 2.4 feet. What's something else? James. Right. 4 o'clock, 3.9 feet. All right. So that's really all the important information that we need for right now. So at 4 o'clock, it was 3.9 feet. Now, someone raise their hand, tell me what they want us to tell them. What is required? What do we need to know? Ralph. Right. We want to know what the depth of the water will be at 5 o'clock. All right. So, what is the depth at 5 o'clock? That's what it wants us to know. So, let's kind of talk strategy now. So, we know it's linear. All right. So, what do we know about linear? Finding a constant rate. First off, what does typically constant rate means? Constant rate typically refers to the what of a linear function? Rate of change, or what's the other word for it? Starts with an S. Slope. So we're probably going to have to find slope of some kind. Now, there's a couple ways you can do this. All right. What's something else that we probably need to do? So, I think finding the slope is where we need to start. All right. And that's definitely kind of what we need to do. But what do you think we're going to use to find the slope? So do you think we're going to use a table? How do we typically find slope? Well, yes, there's an equation or a formula of some type. Look back at your reference sheets if you need to. How do we typically find slope? Sloped. So if you're thinking graph, what do you think of when you think of slope? Blank over blank. Rise over run, that's one way. What's the actual formula to find slope? You guys remember this? So if you're given two different points, you can subtract the two with the rise, which is the y's, over the x's, which is the run. All right. So this is kind of how we're going to do this. So in terms of solving, like what we're going to use, I think a table is the best way to go about this. All right. So I would say let's draw a table. So in terms of solving, we're going to draw a table to represent what we got. All right. So in the inactive, I'm going to draw a quick table. Now, what do you think my x and y values are? So there's two different things. We have time and we have feet. What do you think my x is going to be, time or feet? Time. So I'm going to write in 1:30, 4 o'clock, and then 5 o'clock. And then y would be my feet. So with 1:30, we had 2.4, 3.9. Now, whenever they started this time, we don't know that, but we know that there was zero amount of water in the tank. So there's no y-intercept. Or if it was zero. So we don't have to worry about that. But we can kind of work backwards here. So remember, whenever you have a table, you can easily figure out the rise over run by finding the difference between the two y's and the difference between the x's. All right. So let's think about this logically. How much time has passed from 1:30 to 4 o'clock in hours? So think about it this way. If we were going from 1 to 4, how many hours passed? 3, but we started 30 minutes later. So how many passed? 2.5. So 2.5 hours have passed. So in other words, they added 2.5. Now, how many hours have passed from 4 to 5? Plus 1. All right. How much water was filled between 1:30 and 4 o'clock? So what's the difference between 3.9 and 2.4? So it'd be 1.5. So they added 1.5 water. So if we do rise over run, let's use this part right here for the rise over run, so my 2 points. All right, what's my rise? Which value typically represents rise? Rise. So think about the coordinate plane. Rise means you're going up or down. So which axis is vertical? The y. So my rises are y. So we have y over x. So what's my rate of change in y? What's my difference in the y's? 1.5. What's my difference in the x's? 2.5. So what we did after we drew a table was we found the difference in the time from 1:30 to 4 and the difference in depth, which we then did rise over run, which was 1.5 over 2.5. Now, you may be like, okay, there's no way we can simplify fractions if we have halves. Let's convert these. So let's convert both of these decimals to improper fractions. So if I convert them, all right, what's 1.5 as an improper fraction? So think about it, it's 1.5. So if we're talking in halves, how many halves is 1? 2. And then we add another half. So we have 2 halves plus another half. So how many halves do I have? 3 halves. So we have 3 halves here. So how many halves are there in 2 wholes? 4. Add another half. 5. So this is 5 halves. All right. Now, what's another name for a fraction bar? So a fraction bar can also represent what type of function? Division, right? So if we divide these fractions, so 3 halves divided by 5 halves, we know how to divide fractions, right? How do we divide fractions? Kentucky chicken fried. Keep, change, flip. So we would get 3 halves times 2 over 5. So this would be, if we multiplied that across, 6 over 10, which is 3/5. Now, let's convert 3/5 back to a decimal. And for that, you're going to want this. So 6/10 as a decimal is what? So the first decimal place is known as the what? So if I have 0 point blank, what's that first decimal place known as? So hundredths, thousandths, tenths, 10,000ths. What's that first decimal place known as? The what? The tenths. Well, how many tenths do I have in 6/10? 6. So this is 0.6. So in other words, this rate means we have 0.6 feet per hour. All right, now that's not our answer. So we just found out that the rate is 0.6 feet per hour. So we know that between 4 and 5, there's only 1 hour between them. So what do you think I'm going to do to get my answer? Add 0.6 to 3.9. So then we do 3.9 plus 0.6. Because to get from here to here, we got to add 0.6. So 3.9 plus 0.6. 5, carry the 1, 4.5 feet. That's the depth of the water at 5 o'clock. So there'll be 4.5 feet at 5 o'clock. Quickly. All right, any questions on these word problems? Does that make sense how I went about that one? So that one was a bit step heavy, but you just had to think about it through. So if you could identify that constant rate meant slope, you could have easily figured out rise over run. When in doubt, especially if you're on the inactive, just draw a table. It's a lot easier to do it than to try and graph something or just remember formulas. When in doubt, just kind of draw a table and work your way backwards. All right. Any questions? All right, so we're going to go ahead and do our math minute for the last couple minutes of class. So hold on to both of those sheets. We'll keep using them. All right, so hold on to all those sheets that I just gave you. We're going to keep using them.